Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to go ahead with ellipse topic with respect to chapter conic section. As you are aware, already circle and parabola is already uploaded. So chapter conic section, and still we are dealing with first PUC. Now moving with this, let us move on to ellipse. Now let us try to understand the conic ellipse. What is an ellipse? See, again I'm saying that for each and every curve having the definition, we are trying to obtain an equation. So we are solving a geometrical problem with the help of algebra that we call analytical geometry. So for each of the conic or each of the figure, let us suppose straight line, circle, parabola, we have seen some equation derived in standard form. Similarly for ellipse now. Now first of all, what is the definition of ellipse? So let us suppose that I take two fixed points. In a circle we have only one fixed point that we call radius. Here we have got two fixed points and that we call foci. So let us suppose f1 is here, f2 is here. So both this f1 and f2, which are fixed point, this we call foci. Okay. So foci I give in place of focus because we have more than one, so it's a plural word to be used. So focus is singular and foci is plural. Same like in a circle, no? If you talk about a circle, radius we have got. If I've got more than one circle, we say radii. Okay. Now, if I take a point here, let's suppose P, what the definition says is, it is set of all points on the plane such that sum of the distance from these two fixed points should be always a constant. I mean to say, see here, join these two. Now what should happen? Pf1 plus Pf2 should be equal to some constant. It should be same. Again, if I take one point Q here, again I'm going to join this Q from this two fixed point. Again, what should happen here? Even. So Q, if we take again F1Q or QF1 plus QF2 is also same. All should be equal to some constant. Again, let us suppose I take any point. Let us suppose here. I can just join that. Let us suppose the point is R here. So join this. So what we are going to have? Again, F1R and F2R. If I take the sum, again should be what? Constant. So RF1 plus RF2. So like this, if we take the point, select such a way that sum of the distance from these two fixed points is always a constant, then we get a ellipse. So this is the definition first of all. And what is this constant? A question mark is there for us. We are going to understand that as well. And if we join, when we join all this, no, then we get a curve, and that curve will be ellipse. This is the curve. Okay. Now we have to understand some of the terminologies associated with this. First, make a note of this. So let us proceed with this. Some of the terminologies to be understood. Again, we are not going to go with respect to coordinate axis. First, we are going to understand in general. So let us suppose that we have got that fixed point, that is F1 here, and one more fixed point is F2 here, and I'm going to just join those 2 points. And don't forget, only one line can pass through 2 points. So the 2 points are F1 and F2, the foci. Now, this line which is starting from here, let's suppose A here and then B. This line you can see it passes through both the foci. This AB we call major axis. What is major axis? Any line passing through both the foci is known as major axis. Now here the midpoint of these two foci is here, C, and that C we call center of the ellipse. Center of the ellipse. What is center? Midpoint of both the foci. We can also say that midpoint of these two endpoints, A and B. So now this C is the center. Similarly, try to understand the difference. AB is the length, but A and B for right, A and B, those are coordinates. So this what we call is vertices. We call in parabola point of intersection of the curved parabola and axis of parabola. This point we used to say what? Vertex. Similarly here also point of intersection between the curve and the major axis is our vertices. So since we have got more than one, we say vertices. And there is one more line here which is going to pass through the center of the ellipse and it's perpendicular to major axis. I'm using two conditions here. It is passing through center. When I say just center, no, I can have many lines like this passing here, like this passing here. But I'm saying also perpendicular to major axis. So this line, let us say D and E. This line DE is called minor axis. Now since we have got two axes, no, here it was just said axis of parabola, but here we have major and minor axis. Major axis is that which is going to pass through both the foci as well as center as well as the vertices. Whereas coming to minor axis, it's a line perpendicular to major axis and only passes to the center. Okay, so these are the things we are going to have, and we are also going to discuss each one of them in detail. And now time has come to go with the derivation of ellipse. Then we'll discuss some more terminology as well. Okay, now we are going to go for a 6-marker derivation on standard form of equation of ellipse. Kindly make a note of this. Okay, before I go ahead, some of the terminology still we have to focus here. Just see carefully. Here, this capital C stands for center. Small letter c from here to here, again from here to here, it is distance between the center and the foci. Okay. Similarly, from here till here, nothing but till this, we call A, and again from here till here, it is A. See, A, B, nothing but here, from here to here. This is A, this is A. So I want this entire length. A plus A will be 2A. So length of major axis is 2A. Whereas this part, this is semi-major axis. Nothing but see, this entire is major axis. Half of that. C is the midpoint of AB. So A will be semi-major axis. So I can just say AB is the length of major axis. Length of major axis is equal to AB, which is nothing but 2A. Similarly, see carefully that from here till here the length is B. Again from here to here the length is B. This is our minor axis. So DE is minor axis. So length of what? Minor axis will be here DE. What is this entire DE length? B plus B, 2B. Okay. So we have understood all, and lastly, see this F1 and F2. See this carefully from here till here. What is this? Distance between these two fixed point foci. So distance between the foci. Distance between foci. Which are those foci? F1 and F2 is this is C, this is C. C plus C, 2C. Okay. So we have understood all the terminologies. Before we go ahead for the derivation, we have to go for one important result, the relationship between A, B, C. What is here? Since 2A is length of since 2A is length of major axis and 2B is length of minor axis, only A will be length of semi-major axis, half of the this entire length is 2A. When I say this entire length is 2A, this will be what? Half of 2A, nothing but A. So the relationship between we are going to have A, B and C. We are going to derive what is A? Semi-major axis. What is B? semi-minor axis, and what is C? Distance between the center with any one of the foci. Either you can say this distance or you can say this distance. Both are what? C only ultimately. I hope this point is clear. Let us move on to the derivation on the relationship between this ABC. Kindly make a note of this first. Yes, dear students. Yeah. Dear students, having understood the basic concepts, let us move on to relationship between, as I said, no, we are going to derive relationship between ABC. That's what here. Relationship between semi-major axis, nothing but A, semi-minor axis B, and the distance between the focus from the center of the ellipse. And this is also going to give an answer for us that when we said no definition, it is set off all those points such that sum of the distance from two fixed point is always constant. What is that constant? We will come to know. Okay. Now, as per the concept, now let us say that I just taken O. O need not be origin, just O. Okay. Now the distance between this and this, nothing but center and the foci, is C. The distance between the end point of minor axis and the center is B. Let us join okay, now having this, let us join this QF2 and QF1. Now from the definition of the ellipse, by definition, what should we have? It is set off all those points such that sum of the distance from the two fixed points should be always constant. So here, see, with respect to P, PF1 and plus PF2, PF1 plus PF2 should be equal to, now coming to Q, QF1 plus QF2. This I'll take as equation number 1. Let us not take in consideration R, only what is required that we are taking. Now before we go ahead, try to understand some of the things again. We know that the distance between the center and this point P will be A. Okay, now see carefully. From the diagram, we are going to find one by one. First, let us take PF1 plus PF2. From the diagram, what is PF1? PF1, see here, from here till here the length. Don't forget again, from here to here the length is C. Correct? So PF1 is this length plus this length. What is this length? C. Okay, and what is this length? A. So that is C plus A. Right here, C plus A. Okay, PF2, this length. See carefully. If I take this marker, this is the cap. I want this length. So what we do? From this entire length, remove this length. I want this cap length. Again, I repeat. I want this cap length from to find this length from the entire. Remove this. Correct? No. So similarly, I want to find this length. That's what we know. PF2. To find this length, what we can do? From this entire length, remove this length. From this entire length, nothing but OP. Remove OF2. Correct? Now, what is OP? A. So, this one is A. Remove what? C. Remove is what? Minus C. So, you can see plus C and minus C will get cancelled. A plus A, 2A. So, PF1 plus PF2 is equal to 2A. This is also giving us the answer. We said the sum of the distance from two fixed points should be always a constant. And that constant is what? Length of major axis. Because 2A is what? Length of major axis. So length of major axis. Fine. We'll take as equation number 2. Okay. Now what next we want? Don't forget, I want QF1 plus QF2. Let's take it here. Coming to QF1 and QF2, can we see a right angle triangle here? The right angle triangle which is there here is QOF2. So, in right angle triangle, which is that QOF2. QOF2. Now, I want this length. See, QF1 and QF2. See, I'm going to only consider this triangle. Whatever I will get the answer for this, that is QF2. Same answer I can say for QF1 also, because these two triangles are symmetric. So both are actually same, because why? This length is also C and this is a common length. I can say both the triangles are congruent. RHS postulate. Anyway, coming to this, in this rectangular triangle, can we see that QF2 square is equal to OQ square plus OF2 square. What is OQ? OQ is B. What is OF2? Yeah, OF2. What is OF2? C with a square. Now, very simple. What is, since I want OF2, yes, what is, I mean to say QF2. QF2 will be square root of B square plus C square. Don't write plus or minus, because QF2 is a length. Length cannot be negative. This is my equation number 3. So now I can erase that part. Now I can erase. I just kept all this as it is so that the things are clear for you. Okay, now let us proceed. See carefully, pay attention. Ready? So now, ultimately, our objective was to substitute whatever we are getting, the findings. So with this one we got as 2a, and this one. Okay, don't forget QF2 and QF1 both are same, because these two triangles are congruent. So put equation number 2 and 3 back in 1. When I put in equation number 1, we are going to have PF1 plus PF2 as 2a is equal to QF1 is, and QF1 QF2 both are equal to root of B square plus C square. So I can say root of B square plus C square plus again root of B square plus C square for both of this value. Now since both are same, I can say it is what? 2 times of root of B square plus C square is equal to 2a. 2 and 2 will get cancelled either side. Remaining is a is equal to root of a square plus b square on, sorry, I mean to say b square plus c square on squaring both the sides. What we will get? A square is equal to b square plus c square. So this is the relationship between semi-major axis, semi-minor axis, and the distance between the center and one of the ellipse. That it obeys a Pythagoras triplet. So here you see, this is B, this is C. From here we also came to know that the distance between one of the foci and endpoints of minor axis is what? A semi-major axis length. Okay, so this relation we are going to use frequently in all our problems and also upcoming derivation. This is not a derivation for 6 months. This is a concept between what? Relationship between semi-major, semi-minor, and distance between the foci and center of the ellipse. Kindly make a note of this. Yes, students, having understood the definition of ellipse and the concept and some relation between semi-major, semi-minor axis and distance between the center and one of the foci, now time for the 6-marker derivation, and this has come in model question paper number 1, part E, and it's a 6-marker. See, you may be wondering that anyway for cos of x plus y 6-marker question is there, then why sir is going for this? It's not only about the current batch, it's also about the batch, upcoming batches also, where in the month of December, where we have got second quarterly test, where you have got conic section, and this derivation from conic section, it will be ellipse or hyperbola or parabola, can be asked for 5 marks. Thinking about them also. So surely for under board examination, you may not go for this, but for solving the problem, concept is required. So that I complete, then I'll go for different forms of ellipse, and then we will go for the problems as well. So define ellipse. So I'll give the definition again here, because definition will carry 1 mark. And ellipse is the set of all points in a plane such that the sum of the distance from these two fixed points is always what? Constant. And then they are saying derive the equation of ellipse in standard form. This is the standard form which we have to derive. Okay. Now let us move on one by one. Focus and pay attention. Listen carefully. Now moving on to the diagram. See, on this curve we have got infinitely many points, and that point is taken care by, all this point is taken care by p of x comma y. As I said in all the remaining chapters like straight lines, circles and parabola, whenever I want to talk about all the point lying on the curve, the general point is taken as x comma y without any index. Now the center is origin O, and now you can see the major axis and minor axis are coordinate axis. Next, the distance from the center and one of the foci is C here. Similarly, again the distance between the foci and the center is C. And since this point F2 is lying on x-axis, so it should be of the form C comma means x comma 0. So C will be as it is. Write it properly. C will be as it is because length is C and y coordinate is 0. Similarly, for this lies on negative part of y-axis. So F2 coordinate should be minus C comma 0. Now let us join this F1 and F2 with respect to the point P, and very clearly you can see I have made sure P of 2 should not look perpendicular. It can be anywhere. Okay. Now from the definition of ellipse, we can say very clearly that sum of the distance nothing but P of 1 plus P of 2. P of 1 plus P of 2 should be equal to what we derive. It's a constant, and that constant what? Length of major axis 2a. Now with this we are going to derive the result. Now here we are going to use distance formula. Recall what is distance formula. PQ is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay. When to use distance formula? To find distance between 2 points. Now see carefully. Coming to, let us draw one line here. Yeah, it is looking good. Fine. Yeah. So see, I will be taking this point. See, for P of 1, this I will take as x1 comma y1, and here I will take this as x2 comma y2. So coming to P of 1, by using distance formula, we can rewrite this as root of x2 minus x1. What is x2? X itself. Then minus x1. So minus x1 is what? Minus c. So let I write it a bit more perfect. Nothing wrong. I just thought that the bracket is overlapping negative sign. Whole square. Since already small bracket is used, I have given a rectangle bracket. So x2 minus x1 the whole square plus, let us extend the root, plus y2 minus y1 the whole square. Y2 is y, y1 is 0. So y minus 0 the whole square plus P of 2. Coming to P of 2, yeah, P as anyway x2 comma y2, and this one I can take as x1 comma y1. So it is square root of x2 minus x1. So x minus c the whole square plus y2 minus y1, y minus 0 the whole square. Make sure extend the root completely. Let it cover the entire term, is equal to 2a. Now simplify. Square root of minus to minus is plus. So I will get x plus c the whole square. And here y minus 0 is y with the square plus square root of x minus c the whole square plus y minus 0 is y with the square is equal to 2a. Now see, we have got square root. I want to remove square root. What we are going to do if we have got square root? We are going to square on both the sides to remove the square. Correct? No? But before I go ahead, listen this logic here. Root and root. So I have got root, some term. I'll take this one to explain entire term as some t1. Then we have plus here. Then here root of t2 is equal to 2a. Correct? No? Now see, if I square directly on squaring, if I do, see what happens. Squaring here also and here also. What's going to happen? A plus b whole square, no? So root t1 the whole square plus root t2 the whole square plus 2 times of root t1 and root t2 is equal to 2 square is 4, so 4a square. What I'm trying to make you understand is, before going for squaring, we had how many roots here? 2. Why we are squaring? To remove the root, or at least reduce the number of square root. After squaring, you see this square root will get cancelled with the square, this square will get cancelled with the square. But you see this term, root t1 and root t2, nothing but again we have 2 roots. So beginning also we had 2 roots, now we have got 2 roots. Beginning it was sum of 2 roots, now it is multiplication of 2 roots. So no use, no advantage if I square directly. That's what I tried to explain here. So I'm not going to take directly squaring on both the sides, because ultimately I will have this one without the root, this one without the root, plus 2 times of this product. Okay, I hope the logic is clear. Then what to do, sir? Should we not square? We should square, but okay, this is not part of the diagram, means derivation. Just I made you understand. Now what to do? What we will do is, since we are squaring to remove the square root, at least make one of them alone here. See the benefit. Now, for example, I transpose this because sum of 2 terms. Now, see carefully. We are going to have root of x plus c the whole square plus y square is equal to 2a minus root of x minus c the whole square plus y square. Now, see the advantage of squaring on both the sides. On squaring both sides, what we are going to have? On squaring both the sides, square root of x plus c the whole square plus y square is equal to 2a minus root of x minus c the whole square plus y square. For this entire term we are squaring. Again for this entire term we are squaring. Now you see, since I'm squaring now, very clearly you can see that this square root and this square will get cancelled. Now we are going to be left with x plus c the whole square plus y square. At least one term is free from square root, which was not the case in this. Okay. Now, and understand this one very clearly, because for hyperbola, no, I'm not going to do all this. One logic I will say you. First understand this. Now coming to this. This is of the form a minus b whole square. What's the formula? A square minus, okay, a square minus 2ab plus b square. In place of a, we have 2a. In place of b, we have this entire term. Minus will get balance. So, let us write down a. A is what? 2a, the whole square. Then minus 2 times of a. What is here? 2a. What is b? Root of x minus c the whole square plus y square plus b square. B is this entire term. So root of x minus c the whole square plus y square the whole square. Okay. Now see, without any difficulty, square root and square will get cancelled. Now let us write down the remaining. This, now see, it is of the form a plus b the whole square type. So can't I write this one? Now see, if I write a plus b whole square, a square plus 2ab plus b square. So if I compare, this is our acting as a and this is acting as b. So from this we are going to have what? X square plus 2xc plus c square. I hope this is clear. Then plus y square is equal to 2 square is 4 and a square. Be careful, this square for both. Then minus 2 2s are 4 a. Then square root of x minus c the whole square plus y square. Now be careful when you're writing this part, don't write here. This is in the right hand side. So make sure write it here. Don't write to the left, then it will be left hand side. It is in right hand side. Now here x minus c the whole square, I have to use a minus b the whole square. This is acting as a, this is acting as b, minus as it is. So we are going to have x square minus 2xc plus c square, then plus y square as it is. Now comes simplification. See sum of the term, yeah, x square on either side got cancelled. c square on either side got cancelled, y square on either side got cancelled. Now what is remaining? See carefully. Remaining is 2xc is equal to 4a square minus 4a root of square root of x minus c the whole square plus y square minus 2xc. Again we have root, yes, but we have only one root. If you could have went like this, we could have got product of two roots. I hope this logic is clear. So now again I want to square on both the side, but to remove what? Root. But one thing is very clear, that if I have got with root two terms involving root, or even if I have got one root also, on expanding I'll get again root, because 2a beta will be there. So from here we learned that why there is no, see this, here we have root, here we have root. Left hand side we don't have root, whereas right hand side we have root. What is the summary of the story? What is the takeaway from this? The summary of the story is, since the root term was alone, it got cancelled. And here, since the root term was not alone, the root is still remaining. So if at all I want to remove this root, it should be what? Alone. So mean to say, remaining term I will transpose. Okay, I will transpose the term not involving root. So one side non-root term, other side square root term. Okay, so see here, 2xc then plus 2xc is equal to what? Even this also no, minus 4a square is equal to minus 4a square root of x minus c the whole square plus y square. 2xc plus 2xc is 4 times of xc, minus 4a square is equal to minus 4a square root of x minus c the whole square plus y square. Now throughout I can divide by 4. It's a multiple of 4. So divide by 4 on both the sides. When I divide both the sides by 4, 4 by 4. Dear students, after dividing by 4, we have got this. So all this 4 will get cancelled. So now from here, on squaring both the sides, we are going to have xc minus a square the whole square, this is square minded, is equal to a square root of x minus c the whole square plus y square the whole square. Yeah, we have a minus, yes, so minus with the square. So now be careful. Again here I have to use a minus b whole square. What is a minus b whole square formula? A square minus 2ab plus b square. In place of a xc, in place of b we have a square. So we are going to have xc the whole square minus 2xc, b is a square, plus again in place of b we have a square, then the whole square is equal to, square will convert negative to positive. So this square for minus a square will be plus a square, and root and square will get cancelled, get only x minus c the whole square plus y square, and there is a bracket. Be careful, this minus a is multiple for the entire term. So minus a square will be plus a square, because I repeat, minus a will be a square because of square here, and root and square will get cancelled, get this. Now see, simplify again. This will be of the form a minus b whole square. So in place of a, here it is x, and in place of b it is c. Minus and minus will get balanced. So we'll get x square minus 2xc plus c square plus y square. And left hand side squares for both. So I can write x square and c square, then minus 2xc a square plus 2 into 2 will be 4, a power 4. Simplify this, multiply in, what you will get? A square x square minus a square, this will be this term, then a square into c square plus a square into y square, a square into y square, and this term no change, x square c square minus 2xc a square plus a power 4. Now simplify further. Sum of the term you see here minus 2 xc a square. This term will get cancelled. Any term more getting cancelled? No. So we are completely free from square root. Remaining is x square c square plus a power 4 is equal to a square x square plus a square c square plus a square y square. Now we have to regroup. Don't forget, we know one relation. What? A square is equal to b square plus c square, which we have already proved. Okay, and in our concept ABC, A is larger than B as well as C. So A is larger of the three. So we know that whenever we write any equation, x square multiple or x multiple should be always positive. So see carefully, here comes the final a warning bell for you, that students are confused. Should we take this x square to the right hand side or this x square term to the left hand side? For that, this is the hint. Since x square and c square is there, don't forget even a is also larger than c. So since I want x square multiple to be positive, if I transpose this, I'll get what? A minus c is positive. Okay, c can have minus sign, but a should have always positive sign. So a x square multiple is a square. So this should not go to the left, this should come to the right, and simultaneously we are going to regroup such a way that variable x square y square will be in one side and the constant will be other side. Now since this x square term is going this means towards the right, a power 4 will written as it is, and this it don't have any variable, so transpose, so this will become minus a square c square, okay, is equal to this a square x square as it is. So this is also done, this also done, and this also done, correct? What's the meaning? Now this one, when I transpose this, we have minus x square c square, okay. Now plus this was the remaining term. So you can see all we have written 1 2 3 4 5, yeah, 1 2 3 4 5 items there. So here you can see x square is common, so x square of a square minus c square, then plus a square y square. Here also a square is common, so you get a square minus c square. Now throughout we can think of, before we go ahead, see this, a square minus c square, come here, see this, a square minus c square. If I transpose the c square here, we are going to have a square minus c square is equal to b square. So in place of this I can write b square, here also in place of this I can write b square. So what we are going to have, a square b square, this entire term is equal to x square, and this is what, b square plus a square y square. Let us divide by a square b square, making the right hand side 1. If I divide throughout by a square b square on both the sides, that I use this side, if we do so now, see carefully what we are going to get. See, I am dividing by a square b square. Let us step by step. So here we have a square b square divided by a square b square is equal to, here we have x square b square divided by a square b square plus a square y square, right, divided by a square b square. Now just simplification. See carefully, a square b square gone, so I'll get 1 here. Here b square gone, and here a square also got cancelled. So remaining is 1 is equal to x square by a square plus y square by b square, or I can write x for this one, x square by a square plus y square by b square is equal to 1, where a is more than b, and this is the standard equation of ellipse. I hope this is clear. Kindly make a note of this. Let I erase this so that there is no confusion. Yes, kindly make a note of this. Okay, dear students, continuing with ellipse, having completed the derivation, let us proceed. Don't forget it is 9 plus marks from all, if I take to consider all the part. Now, coming to the next concept is eccentricity. Eccentricity of the ellipse. Eccentricity we denote by E. What is the definition of this? Now see carefully. If I talk about the standard equation of ellipse, where we have got the equation to be x squared by a square plus y squared by b square is equal to 1, where a is more than b. Okay. Now, as we know that this is the ellipse, actually I've seen some students know when we ask to draw, they will take a scale and draw one line here, then again line, and then join this curve. This is a cylinder type, it's not an ellipse. You have to draw in freehand the way I'm drawing. No geometrical instrument should be used. Try to make sure have your level best that this should look same. Okay, all the four region should look same. Now see carefully. What is eccentricity? So center is origin here. Foci F1 and F2. This length is C, correct now? And this length is semi-major axis. Similarly here also semi-major axis. Now eccentricity is the ratio of these two lengths. E is equal to C by A. So it is the ratio of distance between the center and any one of the foci and semi-major axis length. And from here we can also get one important information. What? From the diagram we know that C is less than A. C is this length and is entire. So if I just cross multiply, inequality chapter we have discussed that whenever you divide or multiply by a negative term, inequality will change reverse, but for positive term it will remain same. So either cross multiply, or if I divide by A where A is positive, C by A less than A by A will get cancelled. C by A is less than 1, and this is what? Eccentricity. For any ellipse, eccentricity is less than 1. This will be one more way of identifying which conic it is. Okay. So whenever eccentricity is less than 1, not only that, C by A both are positive. C is also positive and A is also positive, due to which the division of this is always what? Positive. So eccentricity of ellipse should lie between 0 to 1. Therefore, ellipse eccentricity is open interval 0 to 1. One marker question it can be. Okay. So eccentricity we have discussed. Now let us try to move on to latus rectum. Latus rectum. I will take the same diagram which is present here. What is latus rectum? We call parabola. In parabola, the latus rectum was, if I have got this as axis of parabola, any line passing to the focus and perpendicular to axis of parabola. Correct? No? Same thing here also. Any line passing to the focus, and I write focus F1 here. Any line passing to the focus and perpendicular to major axis. So here perpendicular to major axis. So this, let us suppose okay, A is here. So I will take this as some A, yeah, B. So AB is the latus rectum. Now the thing is, I want to find the length of latus rectum. Okay, let us try to solve this. See carefully. From the diagram, AB, whatever length I want to find, can you see this entire length AB, this length whatever is there, and this length what is there, both are the same. So I can say AB is 2 times of BF1. 2 times of BF1. Now if I know what is this length, only this length, then I know length of latus rectum. Recall from elementary, even from chapter straight lines I have discussed this. If I have any point P of x comma y from here, always this particular length is always y coordinate, given by y coordinate, mod y will take. So here, and this is what? X, correct now? So you can see in place of x we have c. So b coordinate will be c, and I don't know this length, so I'll take the length to be L. So c comma L, and I have to find here, my target is to find L, to find length of lattice rectum. Fine. Now let us go one by one. I will take this as equation number. Okay, I'll take this as 2. What is BF1 now? L. I have to find L, so I'll take this as equation number 1. Now, this is a point lying on what? Ellipse B. B is lying on the ellipse, so it should satisfy the equation, ellipse equation, which is here. Okay, so let us put. I'll take this as 1 better, and this I'll take as 2. Okay, so now put x is equal to c and y equal to L in equation number 1. Then what will happen? X square, x value is c, so c square by a square, plus y value is L, so L square by b square is equal to 1. So solve for L, so transpose this. L square by b square is equal to 1 minus c square by a square, or I can take LCM, nothing is 1. LCM of a square and 1 is what? A square itself. A square by 1 will be a square into 1 is what? A square, minus a square by a square get cancelled, so I will get minus c square. So what we have got? L square divided by b square is equal to a square minus c square divided by a square. I want to find the value of L, so cross multiply b square, so we will get L square is equal to b square by a square into a square minus c square. But between a, b, c we know the relation. We know that what? A square is b square plus c square. Transpose this. We will have a square minus c square is equal to b square. Now this implies L square is equal to b square a square, and a square minus c square is b square. Now since I want L, take the root on both the sides, and when I take square root on both the sides, L is the length. Length cannot be positive, so sorry, L is what? Length. Length cannot be negative, so proceed. L is equal to square root of b square will be b. Again for b square it will be b. A square will be a. So from here very clear, L is equal to b into b, b square by a. This is actually length of semi-lattice rectum, half of the lattice rectum. Now put in equation number 2. As soon as I put in equation number 2, we are going to have AB is equal to 2 times of L. What is L value? B square by A is length of lattice rectum. And I want you to observe this carefully. When we have got this result, B is semi, don't forget B will be here, right? B is what? Semi-minor axis. What is A? Semi-major axis. So it is 2 times of square of semi-minor axis divided by semi-major axis. Okay? Kindly make a note of this. Okay, dear students, before going to the problems, let us understand the 2 forms of ellipse. The first one is the standard form, which we have already learnt, but we have to go with some terminology now. Standard equation of an ellipse. So coming to the standard form, the equation which we derived was x square. Oh, Mike. Oh. So x square by a square plus y square by b square is equal to 1, where a is more than b. Now for all our problems, this will be required. Listen carefully, pay attention. And again, students have a problem with the formulas, but the way we are going to understand, if that is clear, no? Formula we can always frame while solving the problem, but let I discuss in general first. See, for this, since A is larger than B, see, understand what is A. A is semi-major axis length and B semi-minor axis length. Those are in denominator with a square. So whenever x square denominator is larger than y square denominator, we are going to take this as the first one standard which we have derived. Now in this, see the graph of this. Whenever A is larger than B, our ellipse will be a horizontal ellipse. Okay. Yeah. In class I call sleeping potato. Okay. This is a horizontal ellipse. Now having understood this, see, foci, as we know, one is here F1 and here F2. So origin is a center. So for all, what is the center of the ellipse? It's always 0, 0, as we had vertex at origin. Okay, in parabola. Now from here to here the length is C. Again from here to the length is C. So coming to the next point, foci. Coming to foci, that is F1 and F2. It is C, this length from here to here along x-axis. So this will be C comma 0, which we already discussed, and this will be minus C comma 0. So plus or minus C comma 0. Next, if I take this one to be A and this one to be B, don't forget this is also vertices. At the beginning I discussed, but without any coordinates, because we are yet to derive that time. So vertices A and B, and it will be, see, since this length from here till here it's A, again from here to here it's A, so this will be A comma 0, this will be minus A comma 0, so it will be plus or minus A comma 0. Next, A, B, C, D. Coming to D point, what will be length of major axis? Length of major axis, and it is AB, is, okay, right, spelling is. See carefully, this entire length, this length is A, this length is also A plus A is 2A. Next, length of minor axis. Okay, I can have capital M only here, major, and here minor. Minor axis. Let's suppose this, I will use D here and E to avoid confusion with C. DE is, see, this entire length from here till here it is B. Again from here to here the length is B. B plus B, 2B. Okay, so what else we have? Lattice rectum and eccentricity. So F point. See, the way I'm defining, no, I'm just defining as per the requirement of the exercise and as per PUC. So E is equal to, what was the definition we understood? Distance between the center and one of the foci, that is C here. Center is O and foci is F2, distance is C. And semi-major axis length, which is a semi-major axis length here, A. So C by A, and always it will be less than 1. Next comes lattice rectum length. Length of lattice, because you know, lattice rectum. In short, hence I call LLR. Length of lattice rectum, LLR, and we derive it to be what? 2B square by A. So yes, this is for the horizontal ellipse. Now let us come to the second version. Equation I'm not going to change. Here A is more than B, nothing but x square denominator is larger than y square denominator. Okay, you can see here. Now I will retain the alphabet as it is, but the condition is now A is less than B or B is more than A. Correct? Now see, if 5 is less than 7, it also means that 7 is more than 5. Correct? Now coming to the graph of this. Now, see carefully. This will be our ellipse. All the four regions will be same. It will be symmetric. All the four quadrant will be symmetric. Now, see carefully, understand and avoid the confusion now itself. Among these two, was larger? X square denominator compared to y square denominator. So A is larger than B. So A became semi major axis length and B became semi minor axis length. The one who's major, larger, minor, smaller. So come here. Here, since A is smaller than B, I think but B is more than A. So major axis will be on y axis. Now you can see y below y square. Denominator of y square is what? B. B is larger than x square denominator. So this length, right, in black color, this length will be now what? B. This is again what? B. And foci will be here, let us say F1. Again foci will be here, let us say F2. And the length from here till here, see carefully. The length from here till here is C. Again the length from here till here is what? C. Okay. So what will be the foci? Before that, center is again origin. So let's write the same thing what we wrote here. First part is center. Center of the ellipse is again 0, 0, the origin. Here also 0, 0, the origin. In standard form, center is always origin. Then coming to B part, it is foci. Coming to foci, that is both F1 and F2. See carefully. Very clearly, this is C and this is also C, but it's lying on which axis? Y axis. Any point lying on Y axis is of the form 0, y, due to which we are going to have foci to be what? 0, plus or minus C. Here it is plus C and here it will be minus C in coordinate. Next is vertices. Now see carefully. Vertices is point of intersection of major axis with the curve. Correct now? So here the major axis what? Y axis, and here it's the intersection. So see carefully. This is our, let us suppose again A here, and then again take B here. So the vertices. So this entire is B, and here it is again B. So this will be 0, B. Correct now? So 0 vertices A and B, and it is 0, plus or minus B. After that we have length of major axis. Yeah, come on, let us see. What could be length of major axis? It is this entire length AB. Now what is that AB? So B plus B will be 2B. Okay. Next, what is next? E, length of minor axis. Length of minor axis. Okay, now the minor axis is this one. Let us name this. Let us suppose L and M. So this one is our minor axis, and again this length from here to here is A, and again from here to here it is A. So I have not changed A and B position, it remains the same. So what was A here on x-axis, again it is there, but now it is minor. So it will be A plus A will be 2A. LM is what? 2A. Now comes eccentricity. Coming to eccentricity, it is E is equal to, don't learn as a memorize C by A, understand what is C and A. It is distance between the center and one of the foci divided by semi-major axis length. So again come here, distance between the center and one of the foci. What the distance? C. So C, this distance what? This distance is what? C divided by semi-major axis length. What is semi-major axis length? B. So C by B. C by B. And again, who is larger here? Since we know that C is less than, you can see no, this is C and this entire thing is B. C is less than B. So cross multiply. C is less than B is less than, C by B is less than 1. So always eccentricity of the ellipse will be between 0 to 1. Next comes length of latus rectum. So length of latus rectum. So coming to length of latus rectum, as I said, I'll call LLR. C, it is 2b squared by a, nothing but twice of square of semi-major axis divided by semi-major axis. So here whose semi-minor axis? A. So 2 times of a square divided by semi-major axis B. Actually speaking, my dear students, first I hope you are clear. If you just observe one thing, no. If I know this, it also means I know this. How, sir? Very simple. For all this result, no. Wherever we have got coordinate, I think that this will call coordinate. Okay, and even for length also, wherever you have got A, replaced by B. Wherever you have got B, replaced by A. Just check it out. Just check it out. See, here, no, A, C in place of that B. But for coordinate, you have to change the position also, because this is lying on x-axis, this is lying on y-axis. You have to change A and B and interchange the coordinate. So see this. Then you see, now see, apart from that, now if you see, length of major axis 2a. Now here it is what? 2b. Replace a by b and b by a. Minor axis 2b. Now it is what? 2a. Essentially is c by a. Now it is c by b. 2b squared by a. Now it is 2a squared by b. Just you have to interchange the role of a and b if you have coordinate exchange them. So with this, all the concepts are done. Now only problems. So as I said, coming to question paper, all the 3 models, no questions are being asked. So I'll be taking the problem from the exercise and I'll try to complete all the exercise problem from this chapter. Kindly make a note. Dear students, having understood the concepts, now time for problems. See, I'm going to solve the problem and similar type of question will be assignment. Question says in each of the exercises from 1 to 9, find the coordinate of foci, length of major axis, minor axis, eccentricity and length of lateral sectum of the ellipse, and this is the ellipse. As soon the ellipse question is given, you have to first recognize is it vertical or horizontal ellipse. Now, first, if I compare with equation of ellipse, b square, no, it is y square by b square is equal to 1. Don't forget, this is what? Equation of ellipse. So when we compare, see, on comparing these two, in place of a square we have 36, and in place of b square we have 16. So without any problem, we can just say a value is only plus 6. Now plus or minus 6 root of 36. Here, since a is length, b is length, c is length, a, b, c cannot be negative. So a is equal to 6 and b is equal to 4. And we are also going to find the c value. And we know that since here, from here very clear that 6 is more than 4. What is 6? A. And what is 4? B. So a is more than b. So we know that what? A square is equal to b square plus c square. What is a square? 36. What is b square? 16 plus c square. C square is equal to 36 minus 16. 36 minus 16 is 20. Or from here c is equal to root of 20. 20 is same as 4 into 5. Root of 4 will be 2, then root 5. This will be the value for c. Now having this, let us go one by one. They want us to find foci. For this foci we know it is f1 and f2, right? Plus or minus c comma 0. Even if you want, you can draw the diagram of this. As you draw the diagram, foci is here right now. So it will be plus or minus c value is 2 root 5. So 2 root 5 comma 0. Next they want what? Length of major axis. So length of major axis is what? 2a. So 2 times of what is a value? 6. So 2 into 6 will be 12 units. What next? Length of minor axis. So length of minor axis. Okay, small letter we can use here. Since all are small letter used, is 2b. So 2 times of what is B value? 4, right? So 2 into 4 will be 8 units. Next, what? Eccentricity and length of ladder sectum. Coming to eccentricity, it is E is equal to C by A. What is C? 2 root 5. And what is A? A value 6. So very clearly 2 ones are 2 threes are. So value of E will be square root of 5 divided by 3. And you can observe yourself here, eccentricity value which we said less than 1, just by having the concept you can see it's very clear here. Root 5, square root of 4 is 2, and here we have 5, square root of 9 is 3. So this value is lying between square root of 4 and square root of 9. So this is surely less than 3. So denominator is 3. So since numerator is less than 3, so whenever numerator is less than denominator, the value will be less than 1. Okay, and obviously more than 0, because both are positive. Next comes length of lattice rectum. Length of lattice rectum, LLR, is, okay, right in here, LLR, which is 2b square by A, 2b square by A, 2 times of b square value is 16 and A value is 6. So 2 times of b square is 16 divided by 6. So simplify from here. It's very clear. 2 ones are, 2 threes are. So answer is 16 by 3 units. Okay. So we have got all. Kindly make a note of this. So dear students, let us move on to next problem. Question number 9. Don't worry, remaining must be solved. So first let us take on first form. See, whether it is first form ellipse or second form ellipse, always the right hand side should be 1. Here it is not 1. Previous case they gave it the standard form. So first make right hand side to be 1. How to make 36 1? Divide by 36. When divide by 36, we are going to have, let us write it here, 4 by 36. And I use other color. 4 by 36 x square plus 9 by 36 y square is equal to 36 by 36. Without any difficulty, I can say that 4 ones are 4 nines are division. Then here 9 ones are and 9 fours are 36. So from here we are going to have x square by 9 plus y square by 4 is equal to 36. Will get cancelled, get 1. Now see carefully. If I compare this as, means we will take equation number 1 and this as equation number 2. If I compare equation number 1 and 2, in place of a square 9, in place of b square 4, that's what I have written everything as it is. Okay. Then root of a square will be, means root of 9 square, 9 will be 3. Root of a means root of 4 will be 2. And it's very clear that 3 is more than 2. What is 3? A value. And what is 2? B value. So again, A is more than B. Nothing but it is the first ellipse. And I want C value also. Again, we know that C square is equal to, I mean to say A square is equal to, write properly, sorry. A square is equal to B square plus C square. What is A value? A square value 9. What is B square value? 4 plus C square. So transpose this. C square is equal to 9 minus 4, or C, okay, then this is what? 5. Take root on both the sides. C is equal to root 5. So the value of C is square root of 5. Now, since it's a standard first ellipse, the coordinates will not change, only the value we should change. So let I erase that and write down the values one by one. So just we have to, so you can see, benefit. Okay, so now let's go ahead. Plus or minus C. C value is root 5. So we are going to get here plus or minus root 5 comma 0. 2 times of A value you can see 3. So 2 into 3, nothing but here 6 units. B value 4. So 2 into B here. So 2 into, what is B value? 2. 2 into 2 will be 4 units. Eccentricity C by A. C is root 5, A is 3. So root 5 by 3. You can write it here, root 5 by 3. Next, length of lattice rectum, 2 times of b square is 4. So 2 times of b square is 4 divided by a value is 3. So 2 4 the 8. 8 by 3 units. 8 by 3 units. So kindly make a note of this. Dear students, still one more point I just missed while writing the question. We should also find the vertices. Okay, so no problem. Here, vertices I will write. Vertices is given by what for this ellipse, the standard one, plus or minus a comma 0. So for previous problem also same thing, plus or minus a is 3 comma 0. Okay, fine. Kindly make a note. So dear students, moving on to the next problem, question number 2. Recording no? Yeah. We have to find the same old things from 1 to 9. We are in second question. Now you see carefully again equation of ellipse. If I compare this as equation number 1, if I take, and these are two assignment to be taken by you. Assignment both. Okay, now see carefully. In place of a square we have 4, so a is equal to 2. In place of b square we have 25, so b is equal to 5. Now who is larger? See this carefully. 2 is less than 5, but what is 2? A. And what is 5? B. So 2a is less than b, or b is more than a. Nothing but it's a vertical ellipse, the second form. Now as soon as I say second form, among a, b, c, b is larger. So b square is equal to what? A square plus c square. Interchange the role of a and b. Okay, don't forget this point. Now what is b value? 5. So 5 square. Okay, 5 square is 25 is equal to a square is 4. Find c square value. So transpose, this is c square. So c square is equal to 25 minus 4, or which is equal to 21. So take the square root on both the sides. So c is equal to root of 21. Visible? No, I only 2 below. No, yeah, it's visible. So now, since it's a second form, that is, this is vertical ellipse, the entire coordinate will change to y coordinate. Then foci will be 0 comma plus or minus c. This will be 0 comma plus or minus b. Length of major axis. Now it is on y axis. Now b is the semi major axis, a is the semi minor axis. So this will be 2b, this will be 2a. Eccentricity will be c by b, already discussed, and length of lattice rectum will be 2a square by b. Now let us proceed one by one. C is root 21, so we can just substitute here 0 plus or minus root of 21. B value as we can see it is 5. So 0 comma plus or minus 5, 2 times of b. So let us write it here, 2 times of 5, 2 5s are 10 units. Then 2 times of a value is 2. So for length of minor axis, so 2 times of 2, which is 2 2s are 4 units. Next, eccentricity c by b. C value is root 21, b value is 5. Root 21 by 5. Okay, then length of lattice rectum, 2 times of a square is 4 and b is 5. So 2 times of 4 divided by 5. 2 4s are 8, 8 by 5 units. A square is 4 and b value is 5. Yeah, 8 by 5 units. That's it. But this problem done, and this two are assignments. Kindly make a note of it. Okay, dear students, let's move on to the next problem. So again, this is not the standard form. First or second we don't know, but let it be first or second. Always right hand side should be what? 1. According no? Yeah. Yes. So this is 144. Divide by 144 to make it 1. When I divide, so see, let's do the working here. 36x square divided by 144, then plus 4 by 144 y square is equal to 144 by 144. If you use calculator and divide, you get decimal. First take to denominator here. So x square divided by 144 by 36 it is. Similarly here, this is anyway not a big trouble. Direct calculation you can do by 4 tables. 4 ones are 4. Then this will be 4 threes are 12. Borrow 2. 4 sevens are 28. 4 six are 36. Correct na? So we'll get y square divided by 36 is equal to, both will get cancelled, get 1 here. And this, if you divide, now you just see 144 divided by 36, use calculator, you will get 4. You will get 4. So we will have x square by 4 plus y square by 36 is equal to 1. You can just cross check, multiply 4 here. 4 6 are 24, borrow 2, 4 6 are 12, 13, 14. Yes, we are getting. Anyway, you can use calculator. So this we will take as equation number 1. Now if I compare both this equation, see carefully, in place of what? A square we have 4. In place of b square we have 36. So A value is 2, B value is all here 6. Now here very clearly you can see 2 is less than 6. What is 2? A value. And what is 6? B value. Nothing but B is larger than A. It is a vertical ellipse, and the relationship between them is B square is equal to A square plus C square. What is B square? 36. What is A square? 4. C square we have to find. So C square is equal to 36 minus 4. What is 36 minus 4? It will be 32. Simplify further. We can take the square root. So root of 32, which is same as 16 into 2. Root of 16 is 4 root 2. So C value is 4 root 2. Correct now? Yes. Now let us go one by one. C value is 4 root 2. So just substitute here. 4 here. Then square root of 2. Then B value is 6. So fine. Then 2 times of 6 the major axis length. 2 6 are 12 units. And coming to A value 2 it is. So we can just substitute. 2 into 2 will be 4 units. C by B. C value is 4 root 2 and B value is 6. 4 root 2 by what? C by B is 6. Simplify. Without any trouble, we can just say that 2 2s are 2 3s are 2 root 2 divided by 3. Then the LLR length of lattice vector, A square value is 4, B value is 6. 4 by 6. 2 1s are 2 3s are, so 4 by 3 units. Yeah, job done. First, make a note of this and I'll give the assignment. Yeah, dear students, this is your assignment. You are going to divide by 16 and do the same way. Okay, make a note. Yeah. Dear students, let us move on to the next problem. See, the heading is different now. In each of the exercises, 10 to 20, find the equation of the ellipse that satisfy the given conditions. So far, equation of ellipse was given. They were asking the characteristic like foci, vertices, length of major axis, minor axis, eccentricity, and length of lattice vector. Now, they have given you the characteristic, and by using that characteristic, we have to find equation of ellipse. Now you see, question number 10, vertices and foci given. See on which axis it's lying. We know that from our basic school disk concept, any point lying on x-axis is of the form x comma 0. Any point lying on y-axis is of the form 0 comma y. So this is of the form x comma 0. So foci and vertices both are lying on x-axis, due to which our equation of ellipse will be a horizontal ellipse, because only for this foci and vertices lies on x-axis. So equation of ellipse is x square by a square plus y square by b square is equal to 1. Now vertices, we know it is plus or minus a comma 0, and foci is plus or minus c comma 0. Now from here, very clearly, in place of a we have 5, in place of c we have 4. Now what is the relationship between them? The relationship between ABC, we know that. What relationship? A square is equal to b square plus c square. A value is 5, so put here 5 square is equal to b value we have to find, c value is 4. So b square plus 4 square, this will be 25 is equal to b square, 4 square is 16, transpose b square is equal to 25 minus 16, which is 9. So b square value is 9. B square value is 9. And a value is 5. So since a value is 5, from here very clearly I can say, since a value is 5, a square value will be 25. Substitute here. So x square by 25 plus y square by 9 is equal to 1. This will be the required equation of what? Ellipse. On this, you can see one assignment here. Okay. Now let us take the other question number 11. Vertices are given. See, this is of the form 0 comma y, nothing but lying on y axis. Both vertices and foci are lying on which axis? Y axis. So my ellipse, our ellipse should be vertical ellipse, nothing but equation of ellipse will be, equation of ellipse in this case will be x square by a square plus y square by b square is equal to 1, where a is less than b. Now vertices for this, as we know, it is 0 comma plus or minus b. Okay, and foci will be 0 comma plus or minus c. So from here, in place of b we have 13, in place of c we have 5. Now what is the relationship between ABC for vertical? In vertical, b length is larger, so we know that b square is equal to a square plus c square. B value is 13, so 13 square. A value we have to find. C value is 5, so 5 square. So simplify, this will be 169 is equal to a square. 5 square will be what? 25. So if I transpose this, we are going to have 169 minus 25 is equal to a square, or a square is equal to 169 minus 25 is how much? 144. And since b value is 13, so b square value should be 169. Anyway, calculate is there for you in case you think it's difficult to find the square. So a square value is 144 plus y square, b square value is 169. Yes, where this equation of ellipse achieved. Okay, I hope this is clear. Kindly make a note of it. Dear students, let's move on next question. They are given end of major axis is plus or minus 3 comma 0. Recording no. Ends of minor axis is 0 comma plus or minus 2. Now very clearly, again this point is lying on which axis? X axis, because this point is of the form x comma 0. So this lies on which axis? X axis. And this point is of the form 0 comma y. Therefore this lies on y axis. So major axis is lying on x axis, minor is lying on y axis. Therefore the curve should be this, nothing but it is horizontal ellipse. And end points of major axis, nothing but this. Don't forget, this value is plus a comma 0 and this will be minus a comma 0. So straightforward, plus or minus a comma 0 for this. Similarly for this, b will be here. So 0 comma b and 0 comma minus b. So 0 comma plus or minus b. Now from here, without any difficulty, the solution part of this will be from here a is equal to 3. And what is b value? B is equal to 2. Therefore, equation of ellipse will be x square by a square plus y square by b square is equal to y square by b square is equal to 1, where a is more than b. Since a is 3, a square will be, from here what will be a square? 9. Since b is 2, what will be b square? 4. So put here x square by, what is a square value? 9 plus y square by b square is 4 is equal to 1. This is the required equation of ellipse. Yeah, here square should be here. Fine. Kindly make a note of this. Yes, dear students, same type question as 13, but major and minor axis coordinates have gone to y-axis here and x-axis here. So just see, so important is basic knowledge, no? That any point lying on x-axis, y-axis was the form. Okay, always checking the camera whether I want or not. Okay, major axis here, this lies on which axis? Y-axis, and this is of the form x comma 0, so lies on x-axis. So very clear that the ellipse will be vertical. So for vertical ellipse, x square by a square plus y square by b square, a will be less than b, or I can say b will be more than a, both are same. So this will be b, yeah, and this will be plus or minus, here also plus or minus a comma 0. So b is equal to root 5, and what is a? A is 1. When a is 1, a square will be 1 itself. When b is root 5, b square will be 5. So now just we have to substitute. Yeah, a square value is 1, b square value is 5. So this will be the equation of required ellipse. Now come this question. Length of major axis 26 and foci is here. See, as soon I came to know length of major axis 26, we don't have any idea whether it is on x-axis or y-axis, the major axis line. Don't forget, as we discussed previously in parabola also, whenever we are changing the position, length, area, volume will not change. If I talk about the ellipse, which is what? Horizontal. If this is my major axis, when I go to vertical, then also it is what? Same length. Okay, so length cannot decide which particular ellipse or which conic it is. But here as soon we come, oh, it is foci is on x-axis. Foci is on which axis? X-axis. So this will be plus or minus c comma 0. Therefore my ellipse will be horizontal. So c value from here will be 5. And since it is lying on x-axis, major axis will be 2a in length. 2 1s are 2 1s are 2 3s are. So a is equal to 13. Now I want b value also. So we know that for this relation is a square is equal to b square plus c square. A value is 13. B value we have to find. C value is 5 square. So 13 square is 169 is equal to b square is equal, sorry, plus here b square is 25. Transpose this. B square is equal to 169 minus 25. So b square is equal to 144. And since a value is 13, a square value will be 169. Now equation of ellipse. So equation of ellipse is x square by a square plus y square by b square is equal to 1, where a is more than b. So let I highlight the value of b square and a square. So b square is 144, a square is 169. So x square by 169 plus y square, b square is 144 is equal to 1. So this will be the required equation of ellipse. Kindly make a note of this. Oh. Okay. Dear students, let us move on to 16th problem. Before we go ahead, no, 17 and 18 are direct problems. At least we had some statement involved in this. Recording, no? Here foci is lying on x-axis, a value is given. As soon foci is lying on x-axis, a will be what? Semi-major axis length. So you have to find b and get the answer. Whereas here, b and c is given and they are saying that center is lying on origin. Nothing but standard form. So b and c is known. Go for semi-major axis a value by taking a square is equal to b square plus c square. Those are direct, so I thought I'll give assignment. Now, coming to 16th question, length of minor axis is 16. Again, no clue we got. Is it 2a or 2b? But foci is lying on y-axis because this is the form 0, y. So this is very clearly saying that for this problem, the ellipse is vertical. So this will be 0, plus or minus c foci. And this will be, since it is vertical, so semi-minor axis will be 2a. So 2 ones are 2 8s are, so a is equal to 8. And from here c value is 6. Now since it's a vertical ellipse, we know that b square is equal to a square plus c square. B value we have to find. A is 8, c is 6, 8 square is 64, 6 square is 36, so this will be 100. So b square is 100. Since a value is 8, so a square will be 64. So now this time it is a less than b. So x square, this is by equation of ellipse. So what next? X square by a square. What is a square? 64. What is b square? 100 is equal to 1. So this will be the equation of ellipse. Okay. Now let us move on to, I think I'll be requiring more space. First make a note of this. I would like to erase that. Yeah, dear students, we are with the last problem. 20th question will be assignment. Center at origin. We have to find equation of ellipse. Center at origin, nothing but any one of the two which we have learnt. Major axis on y-axis. Okay, let us have a diagram. Major axis is on y-axis. So from here it's very clear it is vertical ellipse. Passes to the points 3, 2 and 1, 6. 3, 2 and 1, 6 both are lying on first quadrant. And to find any equation of ellipse, we want a value and b value. Nothing but semi-major, semi-minor axis length. Now, equation of ellipse is, this is x-axis and this is y-axis. Now equation of ellipse will be x square by a square plus y square by b square is equal to 1, and in this case a is less than b because vertical. Now these are the point lying on the ellipse. Don't forget when we derived, let it be any, not only particularly ellipse, any geometry. Whenever any point is lying on the curve, it should satisfy the equation. And always we have taken the general point to be x, y. So it means this 2 should satisfy the equation. So x value will be 3 and y value will be 2. Similarly, x value will be 1 and y equal to 6. And then we are going to find the values of a and b. So this I will take as equation number 1. So put x is equal to 3 and y is equal to 2 in equation number 1, because it is passing to nothing but it's lying, the curve is lying on, or this point is lying on the curve, so it should satisfy the equation. So this will become, in place of x 3, so 3 square divided by a square plus, okay, this is a, mind it, y value will be 2 with a square divided by b square is equal to 1. 3 square is 9 by a square plus 2 square is 4 by b square is equal to 1. This is my equation number 2. Similarly, x value is 1, y is equal to 6. So So put x is equal to 1 and y is equal to 6 back in equation number 1. So we are going to have 1 square by a square plus 6 square by b square is equal to 1. 1 square is 1 by a square. 6 square is 36 by b square is equal to 1. Okay. Now from here I have to find a and b value. It is same like our school days, no? System of linear equation. We used to either solve by elimination, substitution, cross multiplication, same logic, but it's not linear equation, it's non-linear because degree is 2, but method will be same. So let us not go for any substitution to make the linear. No, not required. Now we want to solve 2 and 3. So let us solving equation number 2 and 3. What is equation number 2? 9 by a square plus 4 by b square is equal to 1. This is my equation number 2. And here 1 by a square plus 36 by b square is equal to 1. This is our equation number 3. Now having this, either eliminate a square or b square, left to our choice, and for that we have to make our multiple same. So here you see a square multiple is 1 and a square multiple here numerator is 9. So I can multiply 9 here, and here I multiply 1. I could also went for b, but this will be easy. At least for 1 into any number is what? Same number. So first equation will not change. So 1 into this will be 9 by a square plus 4 by b square is equal to 1. Now 9 into 1 will be 9 by a square plus 9 into 6. 6 9s are 54. Borrow 5. 9 3s are 27. 27 plus 5. 28 9 30. 32. Let's cross check again. 9 1s are 9. Okay, 9 6 are 54. 9 27 28 9 30 31 32. Yes, it's right. Now if I change the sign, elimination, what we do, change the sign from plus to minus and minus to plus. So here there is no sign, which means plus, change to minus, plus will change to again minus, again plus will change to minus. Without any difficulty, we can see this is gone. Now let us go for remaining. 4 by b square minus 324 by b square is equal to 1 minus 9 is minus 8. Now here LCM, again I repeat, 1 minus 9 is minus 8. LCM of this will be b square, they are the same. And now 4 minus 324 will be minus 320 is equal to minus 8. Negative will get cancelled. Now from here, simplify. 8 1s are 8. 8 4s are 32. So 8 40s are here directly. So cross multiply without any difficulty. We can say that b square is equal to 40. We have got b square value. We also want a square value. Either you can put in this equation, or this, or this. You are free to use whichever you want. But I would like to prefer that equation where the numbers are smaller, because our calculation can be very simple. So I can go with equation number 2 or 3, left our choice. So we'll go for equation number 2. If I put in equation number 2, our equation number 2 will change to 9 by a square as it is, plus 4 by, what is b square, 40 is equal to 1. So without any difficulty, 4 1s are 4, 4 10s are 40. So we are going to have 9 by a square plus 1 by 10 is equal to 1 transpose. 9 by a square is equal to 1 minus 1 by 10. There is no number, it means 1. LCM of 1 and 10 is 10. 10 by 1 is 10. 10 into 1 is 10. Minus 10 and 10 will get cancelled. I get 1 here. So you have 9 by a square. Now 9 by a square is equal to 10 minus 1 will be 9 divided by 10 minus 1 is 9 divided by 10. So very clearly you can see 9 and 9 will get cancelled, or I can just say 1 here each. I can cross multiply, or I can say a square is equal to 10 directly, whatever. And b square is this now, and b square is equal to 40. Now let us substitute in equation number 1. That will be the equation of required ellipse. So let's substitute here. we are going to have equation to be x square by a square is 10 plus y square by b square is 40 is equal to 1. This is the equation of the required ellipse. Okay, kindly make a note of this. Yeah, dear students, this will be the assignment for you. Let I just explain what you are going to do here. Same what we did in 19th question. Major axis is on x-axis, so our ellipse will be x square by a square plus y square by b square equal to 1, and a is more than b because major axis on x-axis. Now x value, y value is here because it passes to the point, and again x and y value, same procedure, and we are going to get the answer for this. So kindly make a note of the assignment here. Fine. So with this, we come to an end on ellipse. Hyperbola is pending. That will be our next video. So I think after hyperbola, we have just statistics and followed by sequence and series. With that, the crash course will come to an end. Fine. So make sure study well, do hard work. Rigorously, you have to work for the success. Okay. So all the very best. God bless you all. And lastly, do like, share, and subscribe to our YouTube channel, Math Universe with Dr. Naseer Ahmed. Thank you all.